on box. I must know because it's still active. I don't know how that must be. I downloaded his version.
Oh yeah, so that should be able to use that as a side element. So
Yeah, I should be able to.
Get started. Good afternoon, everyone. Today, I'm pleased to announce Carmen Dwyer from Applied Research Associate. He's a good friend. And Carmen has over 16 years of project management experience with the ARA. And today, she's going to talk about one of the projects that she has been working on for the past 4 years with the Illinois Center for Transportation. It's about pavement markings on concrete and asphalt surfaces. So I'll let her go, but before we start the presentation, I just want to make sure that to make an announcement about the upcoming presentations. We have really worked hard this semester to have a group of good, really strong speakers this semester. And how many of you now knows who's going to be in the list of speakers in the upcoming weeks? Have you heard any announcements? No? You know Angela, I know, but where did you hear that? Huh? Emails? So just keep an eye on your announcements. We have really a good list of speakers coming up. And this will include next week CE faculty, Carlos Armando Duarte, and then we have Mike Darter, Amit Basin, who's interested in asphalt binder research. And it looks like we have to really do a better job in advertising our speakers. So please make sure that keep an eye on your announcements. And today, Carmen will start her presentation. Yes, go ahead, Carmen.
Thank you very much, Hassan. And thank you for inviting me here today. This project is something I've been pretty passionate about. To give a little background on it, I submitted the research idea for this project in 2008 to ICT. It was then selected. We applied for the contract and won it. So it began late 2009. So 7 years later, from an idea to I'm presenting the guide to you, is how long I've been involved with this. So I'm pretty passionate about it. And this is the first presentation I've given to an audience in Illinois. I actually gave a couple along the way at the Illinois Traffic Engineering and Safety Conference too, throughout the progress of the study. So for this presentation, I'll be going over the objectives of the study, the metrics that we use to evaluate the performance of the pavement markings, a marking index that we developed to kind of set the threshold for the service life for the markings and development of the guide, our test site selection, which was a pretty intensive component of the project, and then, of course, the final results. Okay, so the overall objective was to develop this guide. At the beginning of this study, the state of Illinois had many different types of markings that were approved, but different districts and regions could expect different performances depending on things like climate, traffic, etc. And it's better to plan if you have some type of guidance than to have just a whole list of markings to choose from. Their only guidelines would be their experience that they've had with the markings that they've tried. So that was the objective. And what you can see here is just kind of like the initial beginnings of the matrices for selection. This got fine-tuned at the end of the study, but this is just the beginning ideas. Of course, as you can imagine, traffic, how much the volume of traffic drives over a marking could affect its wear. Whether the marking is placed on a concrete or asphalt pavement can determine how well it'll remain bonded to the pavement. Different surfaces work differently with the different types of markings. And then the biggest factor, snow removal. That is a marking's worst enemy. That ended up being a much bigger factor in their final results than what traffic was. So then the second component of the guide is an installation inspection section for practitioners, IDOT inspectors. Any local agency that's going to use this could use this as well. But there's inspection sheets at the end that help them identify things they should be looking for and that are in their specifications during installation. Oftentimes at the end of a construction project, markings are in construction. They're so glad to be getting the work done that markings kind of get not consider when watching for certain things that need to be done correctly, and they are. Like this first couple photos, I apologize, I don't have my laser pointer with me today, but these first couple photos here is a foreman of a striping crew calibrating the bead guns on a marking placement. Actually, this is for a test section I was going on. These are the bead guns up top. He's calibrating the yellow beads for an edge line. The second two photos, that is a tape placement. Now, if it's markings, or excuse me, if a tape is being placed on asphalt, it's inlay, but this is an application on a concrete pavement, so they had to place an adhesive first. And the second photo on the bottom is the tamping procedure. Different states will have different requirements in their specifications, but for this particular job that I was on, the tape had to be tamped 6 times. What you see in the next photo on the far right up top is a wet test that I do to perform to see if the surface is sufficiently clean and ready for accepting the marking. So if that little drop of water had beaded up, that meant there was enough latency on the pavement that it would not accept the marking. You would not have a clean enough surface to place it. But if it spread out like it did in this photo, it was ready. The bottom photo is just a kind of quick method for evaluating if the marking is retroreflective. And I'll describe what that is in a upcoming slide here, but essentially it means if it's reflective or not. And the area behind that person's shadow, you can also see kind of the disbursement of the beads, which is another quality you want to make sure is correct on your marking placement. And I should also mention, as you saw in the previous slides, I listed marking A, B, C. Those are different options. Oh, thank you so much. All of your, if you drive, you're familiar with markings, but you may not be aware that there are more. There are more options than just paint. What you're seeing out there is anywhere from 4 major types of markings. Paint being one, and that is the least expensive marking type. Tape is another. Thermoplastic, you may be familiar with that. It's just a plastic material that's heated up and then placed on the pavement. Sometimes it's preformed. And then the fourth is a plural component, which is unlike paint. It's still liquid like paint, but it is 2 components that are not mixed until just before placement. So if you've seen a striping truck that has 2 large tanks on it, one tank is the pigment, and then the other one is the activator that gets it to bond to the pavement. So that all flows through the lines in the system of the striping truck and gets mixed just before it gets placed on the pavement. Okay, so the metrics that we use to evaluate the performance of the markings were 1, retroreflectivity, and 2, presence. So this first photo here is the retroreflectometer that we used. Well, maybe this one's dead too. Nope. This is identical to mine. It works. There we go. There it is. So I brought it with me. If you'd like, after the presentation, you're welcome to come up and look at it. That's about a $20,000 instrument. So we were very careful with it when we were using it out in the field. And it measures the reflectivity of the markings. And then I'll describe that again in the very next slide. And then presence. What I decided years ago on the largest test section I was ever a part of, we had one marking that failed, or was failing, becoming debonded before any snow removal. And I recognized that for that client, I thought, retroreflectivity it's important, but it's not telling the full story. So we developed this device that took standardized photos of the markings and then processed it through an image analysis so we could get a quantified measurement of how much of the marking was material was missing each year. And I have that with me as well too. It's nothing more than a little Walmart tub with a camera mounted on the top and lights inside. Okay, so retroreflectivity is simply a measurement of the amount of light from the headlight of a vehicle out to the marking that returns to the driver's eyes. You're probably familiar with the term retro. It means something that's back. Same thing here. not all reflectivity is a perfect reflection. So we're talking about the amount of light that returns to the source. And in this case, it's not a perfect return. It's actually what comes, we're measuring the light that actually comes back. Now, obviously, as you can imagine, vehicles are all different headlight heights, where the driver's eye is at, is it, different locations. Some drivers look further down the road, some look closer. So we have a standard that helps us measure that for all marking types. So the ASTM E1710 sets the distance from the vehicle headlight to the optic, the bead that's on the marking that provides the reflectivity at 30 meters. You'll oftentimes hear this called as 30-meter geometry. This was set by the European Committee of Standards. It's, and their abbreviation is CEN. So you'll hear about the CEN 30-meter geometry. But that also means that they've set this angle. This is called the entrance angle of the headlight to the bead, 88.6, and then this angle is called the entrance angle, the observation angle back to the driver's eye. All right, and I was going to pass something around just since I saw that bead. Again, if many of you have been on any job site, you might have seen these beads placed, but I've got some samples here. This is a traditional glass bead, most common bead optic that you'll see placed on a marking, and I have with me some of them are higher end, much more expensive optics that you can place on markings. You just keep passing these around. I believe this one's called a Visi bead, and this one looks a lot like a really small aggregate, but it is reflective. And they make this in white as well and this in yellow as well. Those are just some examples. Okay, sorry, back to presence. So there is a standard, albeit very simple, on presence of markings, and this is it, ASTM D913. You simply take literally this photo here of these marking types out to your markings, and you determine whether or not they fall into the 10% up to 100% category. Well, this is clearly very subjective. So taking the photos that we collect from this device right here, and we have different templates here. You can see I've got, this is a lid with we'll call it a stencil cut out at the width of the marking. I have different lids for different widths markings, but you then take those images, put them into this program we called Mark Analysis, and it converts that image to a binary image in red and white pixels. So you simply then the program simply then calculates the number of red versus total. So this laser pointer's died, but in this, oh, now it's back. This marking is 15.3% missing, or an 85% presence. And we have they've upgraded this along the way where we can batch process markings as well too. Okay, so just to reiterate, the objective was to monitor the markings for both reflectivity and presence, and with the assistance of the technical review panel at meetings we held, we wanted to determine what the minimum acceptable reflectivity was for the panel, as well as the minimum percent missing, what they would consider failed. And during the early years, like the first year, we actually, since we'd already been doing this for another client, the Illinois Tollway, where we needed to make recommendations on where to restripe, and we were using these same metrics, it became pretty apparent to me that we needed a method for combining both of these metrics consistently. So as many of you probably already learned about the PCI for pavements, we use these two metrics for a pavement marking index. So, but I also just wanted to mention here that, of course, in the final recommendations of our selection, not only using that index, we considered compatibility, which obviously presents itself, compatibility with the pavements, but that presents itself and oftentimes the presence. And we also considered the life cycle cost of the markings. If you have one that's really lasts 10 years, but it's the most expensive, well, it's a better option to go with the one that lasts 5 years and only 1/10 of the price. So we did consider that as well. Okay, so now in these next few slides, I'm going to describe this index to you. We developed it very similar to a pavement condition index, where you start off with a value of 100 being the perfect score, and then you have a deduct for each of the two metrics. We had to determine, well, how would we define what the deduct value should be. And then that happened that they both were on a scale of 100, so we had to then, if you're going to total those two, have a corrected deduct so that you can't get a negative index value. So, determining the deduct value for retroreflectivity. Years ago, maybe over like 2 decades ago, Congress mandated that the Secretary of Transportation develop minimum reflectivity standards on both signs and markings. The standard for signs was finally published in 2009, and they've been working on markings for quite some time. And they have now announced that they intend to release the minimum standards on markings this April. So the timing of this guide for IDOT is very good for them, because they'll be able to use that. But this is the proposed table that's in the proposed amendments to the MUTCD, if you're familiar with that. That's the Manual and Uniform Traffic Code Devices. So we use this proposed minimum standards to help us define where we wanted those cutoffs on the retroreflectivity deducts to be. So if you look on this table, the first option on the types of roads are the 2-lane with center line only. Well, that's a pretty rural road that has a center line only, and all the roads that we're evaluating for our clients are the other roads, mostly highways and interstates. And then based on the speed limit, most of the roads we're considering, the markings we're looking at, are greater than or equal to 55 miles an hour. So this value of 100, and the units for retroreflectivity are millicandelas per meter squared per lux, ended up being the number we went with setting our deducts. So if 100 is the minimum, we want to fail, we want the marking to be considered failed, have an index of, we set that threshold, the total index value, to fail at 60. So this will get back around to why we're doing the combined deduct value. But so we set the deduct to be 100, giving it a value of essentially 0 if the reflectivity was 100 or lower. And then you can see at some point as you get out, this curve becomes asymptotic, and at about 300 millicandelas, the deduct is 0. Okay, so presence. There is no proposed standard on presence, so we had to go with our experience on all the markings we've collected data on to date, and kind of just like what we've observed, what we feel we would consider failed. So that was set at 55. That's where the deduct of 100 will be for that. And we also noticed from the data we have from all that we already collected, beyond 40%, the degradation becomes pretty rapid. And my other notes here are just that we could refine that. Unfortunately, to refine it means you wouldn't be comparing apples to apples from data we've already got. But at some point, that might be something we consider. And then I wanted to point out, you see this term structured markings. If you've ever traveled down south, say in a state like Florida, you might occasionally see a marking that was placed intentionally without 100% coverage. And structured markings, typically the purpose for them is to have a good wet night reflectivity. They're built up. They're a lot thicker than markings you'll find around here. And by allowing water to travel between them, that built up, they'll still give a really good wet night reflectivity. If you've ever been driving on a road at night around here and it's raining, it's very hard to see where you're at. That's why everybody slows down. Well, those don't typically survive around here, that built up because of the snow piles. But one marking type that we have just started testing is methyl methacrylate for the Illinois Tollway, and it is an extremely durable product, and we're hopeful that it's going to give a good wet night reflectivity. But I just want to point that out. The presence deducts that we've got here would never apply to a structured marking. Okay, so here's the curve for that. Again, we set the this pivotal point here, the deduct at 40% to a deduct of 40, and then failing it when it gets to a missing at 55. So the point of this graph that you see here is to show the relationship. Obviously, presence and retroreflectivity are not unrelated, as you're marking material is removed from the pavement, your reflectivity is going to go down. But we also, note this 1 point right here is pretty high. A value of 300 plus is pretty high for a marking that's only missing 20% of its material. So that kind of justifies, some of these points out here kind of justify why we also want to consider marking presence. And then finally, here's the total deduct curve. The 1 point you'll see here in the middle is the only point we wanted to force this line through because of the potential to have a marking that is 100% present but only had a retroreflectivity of 100 millicandelas, and that threshold would, according to that proposed amendment, would be considered failed. So that you could have a total deduct of 100 at that point. So we wanted to make sure that the final deduct was still 40, which would give it a index of 60 to be failed. And here's just some examples. All these points you see here come from that graph that I showed you of retroreflectivity versus presence. They just give you some examples. Like worst case on that plot, you had a retro 66% missing and 58, gave you an index of 0. And you see MCI here. We used to call it marking condition index, and now it's a pavement marking index. But and then at the bottom of the table, you have nearly 0% missing and a really high reflectivity. This is definitely more on the high end. I've occasionally seen some tapes that were well over 1,000. One time I had my retroreflectometer beep at me that it was like 1,900. It was getting towards the end of what it can read accurately, but 1,000 or less, anywhere from under 100 to up to 1,000 is kind of a typical range of marking materials that I've tested. And then, of course, everything in between runs kind of the spectrum of the results you can see in the field. Okay, test site selection. If you've been in Illinois any period of time and traveled across the state, you'll know that the climate varies significantly from the northern end of the state to the southern end. So I contacted the Midwest Regional Climatology Center, which is in Champaign, and they provided me this contour map. What you see here, these contours, indicate the average number of days with snowfall at or above 1 inch. So this line with a 10 means that in this area, there's typically 10 days a year where you have snowfall at or above 1 inch. So you can see down south, they don't get anywhere near as much snow as up north. So at one of our technical review panel meetings, we were discussing this and trying to decide, well, let's divide the state up into, like zones according to climate. Well, this map came in very handy for that because this line with the 10 falls very much in line with Interstate 80, and this line with the 6 days falls very close to Interstate 70. So we decided that everything north of I-80 was going to be considered the northern zone. Anything south of 70 was the southern zone, and in between was the central zone. So this is just a map of the IDOT regions and districts, and that's that contour map overlaid on that. Okay, so now we've decided how we want to divide the state up. Now we have to decide, well, what all do we want to monitor the markings for? There's a lot of different variables to consider that can affect its performance. So the climate is one, the traffic is another. A marking placed on a brand new road, you might think it's more likely to perform better than one that's placed on top of an existing marking at maintenance striping. Of course, pavement type. Thermoplastic does not bond well to concrete. Most other materials, will do okay on asphalt. These were just things we were considering. We didn't end up doing all these, so this is one of them. Resin type for just thermoplastic, whether it was hydrocarbon or alkyd. Surface application. Was it placed directly on the pavement surface, or was it going to be recessed? And there are grinding attachments you can place on trucks that will, at varying widths, will we're talking like, you need a micrometer to measure it, but up to 80 mils is about as deep, or I've seen some cuts as deep as like 100 mils, but 40 mils is not uncommon. It's just barely cutting a groove into the pavement surface, because markings themselves are only typically maybe 20 mils thick. You put a bead in it that's only another 10 mils above that. Now you've just got 10 mils clearance between the marking and the surface of pavement. We're talking very thin, but it is enough to keep snow plows off of them. Snow plow rides right over them, and will extend their service life by placing that groove. So we wanted to compare that, markings placed in a groove or a tape that's inlaid versus surface application. Wet reflectivity versus dry, that really wasn't in our budget. It's a lot of extra testing to do a wet test. It was something we talked about. And then long line placement with trucks versus hand carts for letters and symbols. So all but the resin type, the wet, and the application type were evaluated. Now what you see on the blue shades here for the 6 types of markings that are approved marking types for IDOT, you've got paint, thermoplastic tape, and these 3 markings, epoxy, polyurea, urethane, are your 3 common plural component markings. Well, I stated have both, your pigment and your activator that get it to bond to the pavement. So the blue shades here indicate what we, along with the panel, decided we wanted to evaluate. So all these more expensive products, tape and the plural component, were only going to be considered on the higher volume roads. Paint was only going to be considered, sorry, I wanted to skip that. There was something else I wanted to point out here. Oh yeah, again, this only applied to the thermoplastic. So you can see how there's a lot of options. So if we wanted to evaluate all these different things, like just for polyurea, we'll go to my next slide. There's 24, and you want to control all those variables that we've selected. That means you would want one, oh, no, I go back. Now, you know what? This isn't, for some reason on my slide, this is showing it the blue shades, but it's not on here.
Yeah, I can see it.
You can see the blue?
Yeah.
Okay, they can't.
Very lightly.
Is it? Okay. Well, if you can see it, it's what you would see. I'll just try to talk. I'll just try to talk through it for those of you in here. So there's cells inside below these numbers 1 through 24. But what you'll see is, what you would see is that there's only one variable change. So in this particular one, I've got selected. We want to monitor. We want one test site, polyurea site 1, to be high volume traffic in the northern zone on a newly constructed road on asphalt, being placed directly on the surface, and then of course placed with the truck. So on site 2, it's holding all of those the same except for now you want to try it in a groove. So on and so forth, just trying to keep just changing one thing. So that's 24 sites we needed to locate just for polyurea. Now obviously you're not going to find that many, and we were picking. It was not part of the project to install these. What we did was we worked with a couple people from IDOT who had access to all the contracts that were coming up. And lucky us, 2010, when these were being placed, was an exceptional year for IDOT. There was a lot, much more construction going to happen that year than in most years. But unfortunately, that year was a record year for lack of marking material products. There was a major manufacturing lab of the raw material that was closed for a significant period of time, and then there was also an extremely high demand for, from foreign countries for these products as well. Not even necessarily for markings, just this raw product became very hard to get their hands on. So a striping contractor that I've worked with for a year, who has been working for over 30 years, so that was the lowest supply he'd ever had to deal with. So they were looking at not getting markings placed because there's a cutoff of mid-November. So at some point the pavement gets too cold to accept the marking correctly. So fortunately, products did start coming in. We got most sites placed in time, but there were some that didn't get placed till the next year, so that did get one last year evaluation. So working with a couple gentlemen from IDOT, One was tasked with looking for all the sites we needed on the new contracts, and the other one was looking for all the sites we needed under maintenance contracts. And these are all the sites that between these two gentlemen that we identified. Now, if you see a letter like A, so that, poly 1, that was the naming scheme we came up with just from that table. So that name meant something. We could go back to a table and knew what that meant just by the name. So if there was multiples that met the same criteria, that's where you get these letters from, paint 17A, C, D. So now we identified those. Now we had to think about the logistics. What's actually practical to go test? And we didn't need the redundancy of some of these that had all the same criteria. So we located all the maintenance districts that were going to be assisting us with the lane closures to go collect the data. The IDOT maintenance crews provided the rolling lane closures that we went and collected the data from. So we looked at their proximity to those sites, and that did end up helping us decide, what sites, okay, we could live without, or it wasn't practical to do just this one site because it would have taken a whole day to go use that crew to go down and get that one. And this is what we end up with. So I should also mention at this point, there are more test sites in this because the Illinois Tollway was contributing to this study as well. So in the end, we had a little over 70 sites total we tested annually. Okay, so for our final results, these maps here show the accumulated snowfall for each of the 3 winters that these markings went through. So the first winter and the third winter are a little more typical. You can see in like the northern parts of the state, they had this accumulated snowfall, 30 up to 80 inches of snow. And then kind of the more southern parts of the state, the green is anywhere from just 5 up to 30 inches. This mid-year, even the northern part of the state only had at most 30 inches total. So what that did to our data that year meant that the markings are going to appear to perform better than what they typically would because they had so much less snow removal. Our project was actually supposed to end after that winter, but because of that winter, we requested and were approved an extension to our contract so that we could test it for 1 more year and be able to normalize the performance that we were observing from these markings. At the end of that second year, we had at most 2 sites that had failed, and they were likely paint, because paint's the least durable of all of them. And I think the vast majority of them had an index of 90 or higher. So we were far from seeing the real end of service life on them. So this is just an example. This was only after about the second year. But even if we move this out to the third year, you can see how, thermoplastic, which is pretty durable, we did some projecting. We're still studying markings for the Illinois Tollway that were placed in 2006, and they've not seen the end of their service life. So, but the study had to be complete, so we needed to make some estimates, and we were fairly conservative. We didn't want to project that a marking is going to last, longer than it actually would, and we didn't want them to have to. We weren't too conservative either, though, because we didn't want them to budget down the road for markings that could actually last longer than they did. So we're fairly comfortable that we were able to make reasonable projections, just looking back at data we've been studying for the Illinois Tollway for years. Okay, so remember that simple little table I showed you at the beginning, the matrix? We made 4 of those, and this is just the level of detail, the complexity of the options that they have. It provides them a great amount of flexibility in all their options, and really, I feel, pretty valuable information too. So the 4 tables, 2 of them are for maintenance contracts, 2 of them are for new construction, and then within that, one of them is for asphalt and the other one's for concrete. So what you're looking at here is our recommendations for placing maintenance striping on an asphalt surface pavement. You can also see in this table we broke our recommendations out by the northern, central, and southern zone. And of course, low and high traffic. We actually discovered that a better cutoff was 7,000 ADT versus 10,000. And then when you're thinking about maintenance striping, you also need to consider the pavement surface life. If the pavement surface life is the pavement surface life is less than that of marking. You don't want to place a higher end, more expensive marking that could last longer than pavement. You'd just be throwing money away. So that's why we tell you to consider your pavement surface life before you start deciding to. Also, since we were evaluating whether to recess or surface apply marking, this number 2 right here indicates that these costs are based on a groove that's already in place. You're not going to get your money back for the cost of the groove on an existing asphalt surface. I don't know if there's anything else I need to point out here. But, so the cost that you're seeing here. So after this recommendation here, they're ranked as well. Thermoplastic is actually a higher recommendation than paint. It costs more, but look at its service life, and this is an annualized cost. Even though it's a more expensive product, its annualized cost is about half that of paint. So we rank them too when we place them here. And this is based on a 3% discount rate. And then one of the other deliverables we provided to IDOT when we gave them the guide was electronic copy of the spreadsheet that calculates this so they can update as costs change. They can at least update their annualized costs. I can't do anything about if they develop new products. They need us to go test those and monitor them for them again, but at least they can update their annualized costs. So this next sheet is the same thing, maintenance striping on concrete. Here we're looking at 10 years, but you notice a difference. If it's greater than 10 years, this annualized cost is including the price of a groove, excuse me. Yes, so it's more because it's still worth it. You'll get that money back. I think that's the only difference between that one and the asphalt. Okay, so now striping on new concrete. Now we're not worried about what the surface life is. It's brand new pavement. Here, the only difference between surface and recess, we also just want to note that here by surface, we do for a tape, if I can find it. Anyway, that it's inlaid. And then on this column, this recess means placing a tape in a groove. That's the preformed plastic. That's your tape. Okay, and finally, new striping on concrete. There's such a return on investment for recessing that we do not recommend placing markings on concrete, brand new concrete on the surface. You should always recess it. You will get more than your money back. You'll actually save money. It'll be so much more cost effective to go ahead and place the groove, especially in the central and northern parts of the country where there's a lot of snow removal, and especially on high traffic roads. We don't advise placing on the surface at all. That's it. I probably went through it quicker than I planned on. I do have, I do have time, right? What time is it? Folks that are with us online, this isn't going to be of much value to them, but I had some things that I was going to pass around. So up here I have some copies of the guide, and I didn't make slides on this because I didn't think I'd have time in the presentation. But in the back of this are all those installation inspection sheets, and they're based off of IDOT specs. So and you're welcome to keep these if you want them. Peggy was kind enough to print several copies. And the other thing, along with the inspection guides, another deliverable we provided IDOT with was installation inspection kits. So I made a couple from myself as well. But inside here, you'll have, as many of you are probably familiar with it, some of the work you do, a thermal gun. You'll see if you're flipping through some of the installation inspection sheets, the pavement temperature. There's a minimum pavement temperature. When I was placing the methacrylate on the Illinois Tollway last year, I'll go ahead and explain this. Methacrylate is an exothermic reaction, which is really cool. You could actually use this thermal gun, and I could see the temperature increasing on a marking that had been there, for a few seconds already. Just kept increasing. Eventually saw it stop, but it was at a higher temperature than on this hot day. It was at a higher temperature than what the asphalt that it got placed was. So that was really cool. So I'm probably not going to pass this stuff around. You can come up and look at it. But when you're installing a groove, grooves have different thicknesses. And I told you, you can't, it's hard. You're not going to, get a micrometer down there, obviously. So some of these plates are at the exact thickness of what the groove could be. So this one's a 200 mil plate. This is a 110 mil plate. This is a 80, 40, and I guess I had two 40s in case you lose one. So you would place this on the groove, and then you place the straight edge across it. If the straight edge is resting on this, it meant it didn't get deep enough. If there's a gap between the straight edge and this, then they cut it too deep. So they have to do something about that. So there's your groove depth gauges. Something I hadn't mentioned yet, a wet film thickness gauge. This is easy to keep. It's about the size of a business card, and it's pretty valuable. Almost all pavement marking specs will require the material itself, the wet ones, to be a certain thickness. So I can pass this around. There are little teeth on this comb, and each tooth is at a different depth from the edge of the card. So I think I mentioned this earlier, 20 mils is a common thickness for the liquid marking. So you would place this down into the liquid product, and you would look, again, let's say it's the 18 or it's at the 20. If you have product on the tooth for the 18, but it's just kissing the 20, then it got the right thickness. But if it's only on the 16, you definitely don't have enough. Or if it's on the 22, there's too much. And the point of having that be the right thickness is the beads. That you want the beads to be embedded at about 50% of their diameter. You could get a whole lecture on just the importance of that bead being at the right depth. If you remember that one slide I showed earlier where the light's reflecting, it's got to be at that depth to get that proper reflection. If it's too deep, obviously you kind of wasted your money. There's a lot of that bead that's not there. You're not going to get as much. If it's too high, the light will come in the top of the bead and go out the back. So, and not to mention it's probably going to get removed for snow removal. There, I can pass that around. Some really thick markings like some thermoplastics that are 100 mils or that MMA, that comb will only go up to about 80 mils. So then you got to get some duct tape out if you're going to test it. Place that down. Now you can use your micrometer. You pull this back up after they've striped over it. You can put your micrometer on the depth of the duct tape and then on the marking type, and you can make sure the difference is the thickness that you needed. And there's also a test. It's not in the guide, but it is recommended in the report that we did that to make sure the pavement is sufficiently dry. Thermoplastics do not bond well if your pavement is wet. And even because they're hot when they go down, there's moisture in the pavement. That heat will pull it up, create a moisture barrier, and that marking won't bond. So a moisture test that you could do is to place some saran wrap on the pavement surface, tape it down, leave it there for 15 minutes, come back, and if you find a drop of water on that plastic, it's more than, say, the size of your pencil eraser, then there's too much moisture in the pavement. You don't want to place it. They have rules about not placing within, or guidelines about not placing within 24 hours of a rainfall, but that's a really simple test that will help you know whether or not that pavement has too much moisture in it. And then this is not in the kits that were sent to IDOT, but this is a little lens. I was talking about bead embedment. Disbursement you can see pretty well with the naked eye, but this little eyeglass lens will let you get down there and see if you got kind of the proper embedment on your beads. So that's what I've got in my little kit. So I think that's it. Does anybody have any questions? Yes.
What you said the best clearance was above the bead for operation?
Typically, like most of the markings that I've been a part of that were recessed, were placed in a 40 mil groove. The liquid material was 20 mils, and then by the time the bead's embedded, it adds another 10 mils. So now you're talking about just a 10 mil clearance. And the snowplows really truly are like right at the top of that marking. And it is extremely difficult for these contractors to get the right depth when they're placing that groove. As you can imagine, 40 mils, a big truck. So the 100 mils I think is a lot easier. It's when they're doing those ones that are just kissing the surface. That's pretty hard to accomplish. Yeah. That's a good question. Not for the state of Illinois, but I have on some of the test decks that I studied for the Illinois Tollway. because they're placed by hand, I've seen the paint, the liquid material, go down really well. There's some pretty skilled, striping contractors for getting the thickness correct with a hand cart, because they're doing this with a hand cart. Even with a truck, I mean, they have to drive. Once they've calibrated their paint guns, they have to drive at a very specific speed. They're monitoring their speed down to the 10th of a mile. Okay, so with the hand cart, you can imagine there's even less control. But I have seen them do a pretty decent job, even with the hand cart placing the liquid material. It's when they go to place the beads, they're not getting that nice disbursement that you're getting with a bead gun. You're literally grabbing it out of a bucket and tossing it down. So when I was monitoring those, they definitely went into their own separate tracking to keep their data was. The results are very different. And a lot of them were on ramps. It's another thing to consider if you're in Illinois, most of my roads are flat, so it's easy to go ahead and compare. But if you've got water runoff, okay, I'm talking about wet testing because I've done a lot of wet testing. So if you're doing wet testing, if you've got roads with that are inclined, like an Exeter ramp might be, their wet data was a lot different, but their reflectivity too, just because of being placed by hand, was quite a bit different. Yeah.
Do you control your reflectivity by controlling the amount of glass you're placing on the?
That's a very good question too. The glass beads that you see, typically you're not going to get. I've seen some place really well. I have one polyurea site that got as much as 600, but those 800s and 1,000, that's coming from those special beads that you saw. 300s is kind of more common for initial placement of the glass beads. Now the quantity, I've seen contractors flood a line with beads to try to get it, and that's not the contractor, that's in a test site where the manufacturer was wanting to flood it. But what happens then is you get them so close together, the light from the headlights can't get into them like they need to be. They need to be dispersed and not quite, on top of one another. And that's why there's volume requirements and specifications on how much you want to place.
Also, I have another question. You said there are different types of pavement methods, and you said there's thermoplastic and fluoride.
Mm-hmm.
But what's the difference between PEEK and thermoplastic? How do they use it?
Well, they are more or less the same thing. Okay. Some of the preformed, they're very similar. It's about, like I say, some of the preformed, though, can be. I've seen on some airfield markings. Those truly are a thermoplastic that's preformed, and they place them down and they roll these large heaters over the top of them, and it kind of melts that marking into the pavement. Yes, yes. Another interesting, since you mentioned that about the glass bead already being there, thermoplastics have beads in them. And I'd never studied thermoplastics for the Illinois Tollway, which I've been working with for a number of years. It wasn't until I started this project for IDOT that I ever got to study thermoplastics. And I knew that there were beads intermixed, and I just didn't believe that as they got the material got sheared away by plows, that those intermixed beads were going to survive, but they do. Our data showed that. We actually saw reflectivity increase over time, or at a very minimum maintain, and the only explanation for that is that those intermixed beads were there and working. So since we're talking about thermoplastics, something really cool that you might find interesting. When thermoplastic is placed on a road, it is manufactured and placed in a plastic bag, and that plastic bag is part of the formula of the plastic, the thermoplastic. So the bag and everything goes into the hopper where they heat that. The bag just gets melted. There's no waste. It's really neat. The beads and everything are in that mix. Any questions? All right. Well, thank you very much for having me.